536, and I've taken a look at 535, which should be similar, and setting them up. Okay, and there's a couple different ways of doing it, I guess, and so setting this up is kind of a key thing, you know, knowing where your variables and whatnot go. But anyhow, for 35, it says the Ludlow Wildcats baseball team is a minor league team in the Cleveland Indians organization. They play 70% of their games at night. Okay, 70% at night, 30% obviously then in the day. Okay, they win 50% of their games at night, and they win 90% of their games during the day. They need to play more day games, obviously. Okay, and I kind of highlighted this and set it aside, sort of. They lose then obviously 50% of their night games, and they'll lose only 10% of their day games. Okay, and actually we kind of don't need that loss column, and so that's why I kind of highlighted it. But anyhow, so if you look back at Bayes' theorem and we look at it, and then I expressed it more like this, that we can take a look at our night. Our question is, I guess, according to today's newspaper, they won yesterday. What is the probability that the game was played at night? And so we're wanting to know, right, what night and did they win? Okay, so those are the two things, and so we multiply those times each other, night and win, and then we divide that by night times win plus the day multiplied by the win. Okay, day and multiplied by the win, or that'd be 0.35, 0.7 times 0.5 divided by 0.35 plus 0.27. Okay, and I made the big long one like this, and it goes like this. This is equal to our night times our win, okay, divided by, and I'll need a parentheses, our same thing, and I'm going to need two parentheses, night times our win, parentheses, plus our day and win, parentheses, day times win, parentheses, and that should give me my correct answer. So there's about a 56% chance that the game was played at night. Now, if you look also, though, because they set it up a little bit differently, if you look at the example on page 157, we can kind of do it that way too. And again, I don't really need the loss, but in this case, you know, I have the same numbers, and what they did there, if you go to where it says joint probability, okay, that's going to be what our total is, but that our probability of a night and a win is 35% of all games, basically, and day and a win is 27% of all games then. So the joint probability is 0.62, but then I divide that into my night, because that's what I'm trying to determine, is the night and the win, just like they did again on page 157 there. So I ended up 0.35 divided by 0.62, or 0.564516, which is the same answer, and that's basically what I did down here as well. So for you guys, you know, to set up your problem, of course, you're going to have a little different. You got 80% here that complete assignments, right? 20% that do not complete assignments, and then pass will be 90% and 60%. And of course, you're then trying to determine if Mike Fishbaugh, right, what's the probability that he completed the assignments? And so you're basically going to be using the same data, okay, that we had there, and plugging it into either one of these equations. Good luck.